Hey everybody, it's Jake. Right now, I think a lot of us are going through some stuff with everything that's going on, and so I figured it would probably be a good time to have some fun and do some coding. So this is a series that I'm currently calling gropramming, which is just going to be fun, kind of off-the-cuff programming. Today, we're going to get into MIDI and MIDI controllers, and we're going to learn how they work, and then we are going to use them to do fun things in a web browser. So this is going to cover modules, JavaScript modules. We're going to basically cover the Midi API, which is kind of experimental. It works in Chrome and Edge right now. We're just going to do it all as vanilla as possible. So we're going to be just dealing with the core bits here of JavaScript, HTML, and CSS. So I've done some work to kind of like make some headway so that we're not wasting a bunch of time, because there's a bunch of things we could waste time on. But I built kind of a MIDI library for us so that we can kind of like get a jump start here. So first things first, let's take a peek at our setup. So we've got a project folder called 001 MIDI, got an index.html, app.js, app.css, and then a script folder with a midi.js, which is my MIDI library. So let's look at index.html here. We are pulling in a font called Luckiest Guy from Google Fonts. We are pulling in our app.css file. And then down here, we are using script type module for our script midi.js file and our app.js file. The reason we are doing type module is because we want to be able to import from other files. So I believe we have to include both of these here. But once they're registered as modules, we can then refer to them like this. So I'm going to import MIDI from script/MIDI. And so if we look at scripts MIDI here, script/MIDI, export class MIDI. So when we import MIDI, we are grabbing whatever is exported in this file called MIDI. So let's take a peek at, so one thing you need to know with type module is that just opening this as a static file isn't going to work. We have to actually run like it under localhost. And the easiest way to do that is going to be on a Mac. We've got simple HTTP server, which let's look here. Python-m simple HTTP server, and then we specify a port. This comes by default on a Mac. I think Python is like 2.7 or something. If you're using a later version of Python, there's another command to run local server, static file server. But basically, we get into the folder, which is 001 MIDI. That's this folder. Then we just run this, and whatever is in that folder is going to be available at localhost port 3000, right? So here's our file here. So if you remember, we're logging MIDI. So here it is. I have some base style that I've applied to app.css right now, so you can ignore all of that. That's why we get a black background. It's just a little gradient. We can get into that later. I'm going to hide our terminal. So app.js is importing and then logging MIDI. We've got app.css, which has some blank kind of just base stuff that we're going to be using. And then midi.js has two classes. We're going to ignore MIDI event for a second because that's where most of my work went. And it's like, well, we can look at it. It's a lot of this stuff. Like, we're basically describing different MIDI events and giving them names. And so we don't want to look at that right now. We're going to hide that. So we've got this MIDI class that's exported. And let's take a peek at the MIDI API. So this is on MDN. We can see that MIDI is available through this thing called access. And what access is access is kind of this gateway. It's almost like permission. So by saying navigator.request MIDI access, the browser can use that as an opportunity to be like, I'm going to show a confirm to the user that says, hey, are you sure you want to be using this? Like, do you want this website to have access to your MIDI controllers? Then the user can click yes or no. We see it all the time with like microphones and cameras. It's a similar sort of idea that because MIDI API isn't fully implemented, that stuff doesn't necessarily exist yet, but the methods do. So if we want to access a MIDI controller, we have to go through this request MIDI access, which returns a promise. So let's take a peek at that. So I have a constructor on my class, which constructor gets called when you do this. You've seen this before, right? So when I call new MIDI, new class MIDI, and I say, okay, here's a string that I'm passing in, that is what's going into the constructor. In this case, it wants an event as a parameter, and we'll get into that in a second. So it wants a function called onEvent. It can be called whatever you want, but it's going to be run whenever an event occurs. And you can think of an event as I touched something on a MIDI controller, I moved a knob, I plugged something in, I unplugged something. This function is going to be called whenever that happens. Doesn't care what it is. It's just going to always call that function whenever anything happens. We're defining inputs and outputs, which we'll get into in just a second. So that's all happening. That's just two empty objects. That's all happening when we create a new MIDI. Initialize is where we're going to do this request MIDI access. This is the thing that's going to get us access to MIDI controllers that are plugged in. I am returning a promise here so that when we call this method, we can be like MIDI.initialize.then because it's an asynchronous thing that happens. So we're returning a new promise, and a promise is basically like, wait until I do something. I'll tell you when it's time to continue. And that's when we call resolve whenever we want it to resolve, whenever the promise is resolved. So if I say, I'm going to tell you a number, that's a promise. And then I say 3, that's resolved. If I can't think of a number, I'm going to tell you a number. I forgot what all the numbers are in the world. That's an error, and that calls reject, right? So I can't resolve the promise because I can't give you a 3. So then a reject is what happens. So that syntax ends up being, let's say we have a MIDI equals a new MIDI, and then we're going to call MIDI.initialize, which returns a new promise. So we can even say const promise equals that. So our promise, when it resolves, this will be called. So let's say it was a number, like we said. So the promise is I'm going to give you a number. Then we can just alert number. When I can't give you a number, that's what .catch is for. And so then we could say console.error, whatever the error is. And let's say catch gives you an error. So this is the reject of the promise, and then this is the resolve of the promise. So if I said resolve 3, that would be .then alert 3. If I said .reject, I has no numbers. That's going to be our error right here. Okay, that's promises. For some of you, that might have been redundant, but we're just going to keep going here. All right, so we're requesting MIDI access, and hopefully we're being granted access. So it's promising us access. So in our .then, we're going to get access. That's this line right here, function access. In access, we have inputs and outputs. And access requires us to access it like this. So we can be like const inputs is access.inputs.values, which is a function that will return inputs. Same for outputs. What's an input? What's an output? An input, when we tap this, that's an input. I am sending data from here to the computer. Output is when the computer is like, hey, light up the MIDI controller, light up this square. Our computer can do that. This is then an output. So when this is plugged in, we're going to get one input and one output because it's both. So inputs is an iterator. let's take a peek at iterators. So an iterator is kind of like an object, and it's kind of like an array. The way we access everything in an iterator, instead of being like inputs.forEach or outputs.forEach or for let I equals 0, I is less than inputs.length, I++, instead of doing like a for loop or anything like that, in that way, we do a for loop like this: for const input of inputs, for const output of outputs. That's how we iterate through an iterator. So what we're doing is we're calling initialize input on each input in inputs when we get access. In fact, let's just look at this. So we are going to console.log inputs and outputs. All right, here's our MIDI. We got to go back to our app.js. We're going to say new MIDI, const MIDI equals new MIDI, MIDI.initialize, then we're just going to console.log initialized. Okay. Here we go. It might throw an error here. Looks like we're fine. So here's our inputs and here's our outputs, 2 iterators. Now they look empty, right? Let's actually do this so that we can see it. All right, inputs is an iterator, outputs is an iterator. There's no values. There are actually values. Let's do this. So for each input of inputs, for each output of outputs, we're going to initialize an input, output an output, or initialize an output. So when we initialize this input, I'm going to console.log input. When we initialize the output, we will console.log the output. Okay, so what we're going to do is we're going to go through each of these inputs, so the iterator, and we're going to go through each of these outputs, which is this iterator. For each one, we are going to initialize them, and when we initialize each of them, we're just going to log it. What's this? We have 2 different things. We've got MIDI input, that's our each input. We got a MIDI output logged down here, which is each output. Let's take a peek at what an input is. And might as well look at an output too. Now you'll see these look very similar. So our input has an on MIDI message, but other than that, it's very similar to the output. Connection, ID, manufacturer, name, state, type, version, on state change. So the version's the same. The type of our input is input. The type of our output's output. The state of the input and output are both connected. The name is both, it's the same for each of them. It's just the MPD 218. That's actually this name here, MPD 218. And it's manufactured by Akai, which is the manufacturer name right here. Then we get a unique ID for both the input and the output. So the output for some reason is negative and the input is positive. That doesn't matter. All that matters is that we're getting a unique ID for each of them. The connection is closed. We could talk about that later. But on MIDI message is going to be, right now it's nothing, but that's going to be a function that we're going to say whenever this input gets a MIDI message, do something. That's going to go here. Note how that isn't available for an output because outputs don't have that. Okay, so we've initialized our input and output. Let us continue with this little bit of knowledge here. So if we go back and look at MIDI access, you see this access.onStateChange, which is a function. That is basically going to say whenever you unplug or plug in a device, call this function. Doesn't matter if it's this device. I have a keyboard over here. I could plug that in. This will get called because I have access to all MIDI. That's what we requested access for. So after we've requested access, if anything plugs in or gets unplugged, that's when this is happening. So we can do add event listener state change, and that's going to bring in an event, and an event has a property called port. So e.port we're just destructuring it here. So this is the same thing as doing this event, and then port becomes event.port, et cetera, et cetera. It's way easier to just destructure it right like this. So that's what I'm doing, because it's always going to be the same type of event. So it's always going to have port. So we're just going to destructure it here. And we're basically saying if the port.type is an input. So if you remember here, this is the port. Remember, we got a .type of input for our inputs and a .type output for our outputs. If the type is input and the state is connected, initialize again. So this is, we're calling this up here when we load the page. This is needing to initialize the input again. If we plug in another MIDI device, we want to initialize that one too. That's all this is it's saying if it's connected, then we want to initialize it. If it's not connected, then it means we just unplugged it. So we're going to call a method called Teardown Input. Here's the same thing, except instead of inputs, it's for our output. So we're calling initialize output for if it's an output being connected, and then we tear it down if it's being disconnected. All the teardown is we're basically, ignore the send event, but basically we have an inputs object on this class and an outputs object. And we're basically deleting it from that object on teardown. So if it doesn't exist, return, otherwise delete it from our internal memory. That way we're not storing all this information when we unplug a MIDI device, because we're going to, if we plugged it back in, we're going to reinitialize it. So we don't want it to be there. We want a new instance. This send event, all it does is it calls our onEvent handler, which is what we passed into the constructor up here, onEvent. Send event just takes an input or an output and sends a new MIDI event, which is this big class up here, which we don't need to worry about right now. So it's going to call our callback with a new event. I'm just wrapping an event so that it makes more sense to all of us, which will be way easier. So I'm going to uncomment this, and I'm going to uncomment this. I'm going to uncomment this. I'm going to remove that, move this. So the only thing that's missing now is what happens when I press down. That is our MIDI message. Remember, on MIDI message. That was undefined right here, on MIDI message. That's what this is, input at Eventlistener MIDI message. So you can look at that here, MIDI input.on MIDI message. This is in the MIDI input docs on MDN. We can see that Chrome, Edge, maybe Firefox, no Internet Explorer, no Safari, of course. So on MIDI message, we're going to be getting an event that has data. And we're sending that data along. And what's really interesting here, I'm not going to send this event. I'm just going to console.log data. This is why I'm not explaining MIDI event in detail, is because MIDI event class down here exists just to make data pretty. I'm going to log it raw for us right here, and we're about to see it. So we've initialized. I'm going to just clear the console. I'm going to tap a button, tap another button. I'm going to turn a knob, and let's tap a button again. So I'll tap one really quick. Let's clear, and we'll look at a tap. All right, this is event data. So this is what we're logging on MIDI message. This 144 means note on, so it means key down. This 128 means key up or finger off the button. 48 represents which button I tapped. So if I tap another one, we get 49. Here's another one, 50. We'll go back to 49, et cetera, et cetera. So this is key down on 49. This is key up on button 49. And then this last one is 0 to 127, which represents how hard I pressed. So I just pressed 50 a little bit lighter. So now we're 36. Notice how you can't, there's no velocity to a key up. There's no like off speed. There's only on speed. So that's why the 127 and 136, those are different varying how hard I tapped. But the key off or the note off, that's always going to be 0 because there's no velocity to that action. Okay, that's just buttons. So now I'm going to turn a knob. And so 176 represents a knob being turned. It's not always a knob. In this case, it's a knob. But 176 represents, hey, a knob is being turned. Number 9 represents which knob. So I got another one that's 3. I got another one that's 12, 13, 14, 15. So there's 6 knobs, 3, 9, 12, 13, 14, 15. That's just this MIDI device. If I plugged in my keyboard, different knobs would be different numbers and all this stuff. The reason it is the ones it is right now is because the manufacturer said, hey, I'm gonna use these numbers to represent these knobs. There's only a certain amount of numbers you have access to as a manufacturer of a MIDI controller. So they're just using the ones that they wanted to use. And for us, it's 3, 9, 12, 13, 14, 15. The pads are 36, 37, 38, blah, 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 all the way to 51. So I have 36 to 51 are my pads. And I've got 3, 9, 12 to 15 or whatever for my knobs. That's exclusive to this. It's because that's what the manufacturer wanted to do. Now, with our knob, 9 is the knob, remember, the same way 3 is the knob here. That last value is on a scale from 0 to 127. How far have you turned the knob? So I'm going to go all the way to the left. We're at 0. All the way to the right, we're at 127. It's wonderful, right? Well, there's still more. So we were talking about tapping. So you can see I'm tapping and we've got our 144 and 128 for note on and note off. Now what happens if I hold it? Oh, what's this? Well, this MIDI controller has what's called, oh shoot, what do they call it? It's basically pressure sensitive. I've got it labeled up here. Aftertouch, right? So we touched, that's our note on. Then aftertouch is what happens after that point. Now you have 2 types of aftertouch. Type A of aftertouch is called, is it polysynth aftertouch? Polyphonic aftertouch. Polyphonic aftertouch just means that when I'm doing aftertouch, which is holding down and doing pressure sensitive, it's tied to that button. Normal aftertouch is not. Now, what's the difference? So what this device actually is doing, see how it's 2 values, 208, and then another number? So we've got 208.82, we've got 208.79, we've got 208.67. That second value is on a scale of 127. How hard are we pushing after we started pushing? So note on, now we're pushing. How hard are we pushing? On a scale of 0 to 127, that's that second value. The 208 represents aftertouch. What's sad is there's no association between the aftertouch and that button. So I'm going to just press 1 down here. You'll see what I mean in a second. So I'm pressing 1 down, and now I'm doing aftertouch on another button. You can see my top hand here is pushing down. Both of these are firing aftertouch, but we don't know which aftertouch is which. So we don't know which button is being pressed down, which heaviness. That is normal aftertouch. Polyphonic aftertouch, which is not 208, and this MIDI controller doesn't support, is, what number is polyphonic aftertouch? That's 160. So 208 is up here, our aftertouch. Polyphonic aftertouch is here. Now, why is polyphonic aftertouch cool? Polyphonic aftertouch means this event for aftertouch has 3 values, not 2. It would have 160, which is, hey, this is polyphonic aftertouch. Then it would have a number, which would be which pad. Then it would have 0 to 127, which is how hard. That way, you would know when this is streaming through which pad is being pressed. Unfortunately, we don't have that access right now. I don't have a device that allows for polyphonic aftertouch. But that doesn't matter. We can use this because we're only going to worry about one button at a time right now. So anyways, that's what this logging is doing, is giving us that data. Remember, this set of 3 numbers or 2 numbers, that's data. Instead, we're going to call send event, where we pass our device information and our data information into a new event, and this thing just creates something that's going to be a lot easier for us to understand than a bunch of random numbers. That was a little exhausting, but we'll get there. It'll make sense in a second. All right, so here's our MIDI library. I'm going to be giving this to you. You'll have access to this. This file is pretty straightforward. Like most of this code for event is turning numbers into text so that we know what things are. And I got this information from these 2 sites, which look like this and are really boring. So here's polyphonic aftertouch for number 160. The second value is the note number. The third value is pressure. All of this I basically transformed into this so that we don't have to read old archaic PDFs. Okay. Wonderful. Let's move this down. Let's open up our app here. So we need onEvent. So if you remember the MIDI, when we construct it, we're passing in a function called onEvent. And then when we send an event, it's going to call onEvent. So in our JS, what we need to do is we need a function here. Let's just call this handle event. Function, handle event. And remember, this is going to take an event, which is my special thing that was created. And we're just going to console.log event. We're going to spell it correctly too. Okay. Well, looks like we already got some events. Let's take a peek at them. We're not going to console log MIDI anymore. We don't need that. Okay. Yeah, that's fine. Can I just... I don't know which of my things is causing this. It's really annoying. Let's go into this mode and look at info only. Okay, much better. All right, so we've got 3 events. We've got a device connected, another device connected, and another device connected. Let's expand these here. So these are my event. This is my event like API. So A and B are going to be values whenever a value occurs. In the case of connected, there is no value. So here's our device. It's an output, and this device is an input. So what we're basically getting is, hey, a new input was connected, and another new input was connected, or an output was connected. Down here, the input gets duplicated, and that's because it basically occurs twice, because this state change also gets called when you refresh the page. So this fires and then this fires. So we get 2 logs on page load, but I promise that's the only time there's duplicates. It doesn't occur for output, which is very interesting. And it's probably just the way the browser's handling it right now. Okay. Let's simplify this here by saying on this, we're going to grab the device. We're going to get the type. We're going to get A and B. And we'll just do device.type, device.name, and then we'll leave that alone for now. Okay, input. This is MPD 218 port A. That's just the name of this device. So we're logging that device type and that device name. I accidentally touched something, which is why that happened 6 times. Okay, Now, let's look at the type. And in fact, since we only have this single item, what I'm going to do is I'm just going to do we're not going to log the device information right now, just the type. So we've got 2 devices connected. And now I'll keep device type in here. That's whether or not it's an input or an output, because that might be helpful for now while we're trying to understand what's going on. So input device connected, output device connected. Initialize happens. Then after that, we got another input for device connected. Now, what I'm going to do is unplug this. Oh, wow, look at that. Input disconnected, output disconnected. Plug back in. What happened? That didn't, hold on. That's supposed to fire. Let's look. What's wrong here? Console.log, port. Got a little oopsie, and this stuff happens all the time, so refresh. Oh, maybe there was an error. Do I not? Okay. Device connected. Let's unplug. There's our disconnected. Okay, we're connected again. Okay, that's working. I think it might have been my cable. Let me just, it's never the code, it's always the cable. If only that were true. Okay. Okay. Okay, there we go. All right, so that's our plugging in, unplugging. Now, what happens when I tap something? Oh, we got a node on and a node off. Let me turn a knob. Mode change, that's the name of a knob turning. Ooh, we got a little aftertouch because I'm still holding it down. Node off. So note on, aftertouch, node off. Very cool. So let's focus on a single knob right now. So we're going to focus on this knob right here. And the way we're going to focus on this is by saying if type is equal to, remember, mode change, that's coming from right here. That's just the type of event. Then that's the only time we're going to log this stuff. Okay, so now there we go. Okay. Now let's go ahead and say if the type is equal to mode change, and let's just log, let's log A and B and see what's in there. Okay, so we've got a value. Let's only log A really quick. So we've got a value, which is 9. Remember, that's our ID. A ratio is what that is on a scale of 0 to 127, which we don't care about right now. We just care about the identifier of 9. And the label is mode. So it's which mode is changing. In our case, that's the knob number 9. That's the mode. The value is going to be in B. So first of all, let's say if the type is equal to mode change and A dot value is equal to 9, then console.log B. So now this should only occur when I turn that one knob. Everything else is now working. So if you look, turn this knob, everything moves. Turn this knob, nothing moves. Tap these, nothing moves. That's because we're looking for the mode change type of event, and only when it's knob with a value of 9. So that's A, value 9. Then we're logging B, and we're going to want to get that ratio. So this is going to give us 0 to 1, which is pretty nice. So with that value, that's all the way to the left, all the way to the right. With this value, we can do stuff. So let me do a little, I'm going to grab some code. Basically, I am going to draw gropramming is going to be split up into a crazy thing here. You'll see. All right, so we're going to have a ratio of 1 to start. Text is going to be, let's do h1 id equals text. So we're going to grab that here. And when we draw, after we initialize, we're going to set the inner HTML to be gropramming, and it's going to look like this. So this is coming from our CSS. I am going to quickly add, I've got some animation stuff. It's not that crazy. There's not a lot of stuff in here. I'll let you go through it on your own. There we go. Okay, it's working. Basically, each of these letters is a span, and so we're applying some animation on each letter. So this is really fun. So now what we're going to do is I have in the CSS, I'm using CSS variables to define a ratio of 1. Ratio is being used for the opacity, and it's being used for the scale of our ratio here. So if I change the ratio to be 0.5, we get 0.5 opacity, 0.5 scale. We'll bring it back to 1, full opacity, full scale. Gropramming. It's fun and difficult to say. I'm going to give this to you so you can look at that. We're going to close it now. So remember, we have a variable called scale that influences the scale and opacity of this element, this H1 element. So that's this guy right here. I'm going to take this ratio, and let's just say, if we're turning that knob, remember b.ratio ratio is 0 to 1 already, so we're going to say ratio equals this. Whoops. Note how that doesn't do anything, right? I'm turning the knob, nothing's happening. It's because it's just a number, right? What we really want to do is now use this ratio to update the CSS variable. The way you do that is not, one would think, so the best way to do it is you could think of it as, oh, just do text dot style dot, dash ratio equals, goodness gracious. You could think of it in these terms. This doesn't work for 2 reasons. First of all, that's not how you set a variable on an element. Second of all, we don't want to be doing that on this event. We only want to change a value on that event and then use request animation frame to actually animate that change. So for now, what we're going to do is we're going to say ratio equals b.ratio. Then here, we're going to have our animate, which will take that ratio. First of all, let's request animation frame animate. And then what it's going to do is it's going to take the text.style.set property. This is how you set a variable. And then we're just going to say ratio is equal to whatever our ratio is. Then we just need to start that loop. Animate. So animate, which will request the next animation frame to call it again. And then it's just always updating the property ratio to be whatever we've changed this to in the meantime. So this is changing this. This is independent of that, reading this value on every animation frame, which means, let's go here, get this in view. Oh, look what we have here. Oh my gosh. So all the way off, all the way on. Wonderful. Okay, one last thing. I've got that going. Let's make sure that it's always this device, because we're making sure that it's always this knob, right? So let's call this knob. And up here we'll do const knob equals this. I know how funny that is to some of you. Then let's log the device. So we know what we got here, console.log device. We need to get the name so we can validate the name. The name is MPD218. All right. Const device equals this. So if device is not, device.name is not equal to this, then we return. So we're saying this is the knob we care about and this is the device we care about. Now I'm also going to create a new value called pad. And I know that I want to use pad 48 here. And so else if type equals note on, and remember, this is going to be our pad number. A is going to be our pad number. So when this is being pressed for the first time, we're going to say on equals true. And let me just put let on equal false. And then we'll say else if type equals note off, and it's our pad off or on equals false, which is the same thing as off. Else if type is equal to, let's log our type. We want to get the aftertouch. So if type is equal to aftertouch, now remember there's no ID on aftertouch. So what we want to say is and on. So if we've pressed on, we haven't let go, and we're getting an aftertouch, then ratio equals a dot ratio. Aftertouch only has one value, so we only have A, we don't have B. Okay, what is this doing? Let's actually console.log a.ratio. So when pad 48 is being pressed, let's refresh. Here's our ratio. So our size is based on how hard I'm pressing this down. Now, how do we know which one that is? I know that 48's that one because I know that 48's that one. But let's do something else. Let's make it light up. Let's use this as an output. And this is one last quick thing before we finish here. Okay. So let's take function. We'll do notify. That's what we'll call it. And that is going to notify us which pad. It's going to light up the correct pad, and it's just going to blink it. So we'll just say, so I happen to know, I should add this to my MIDI library. Let's add it to the MIDI library. Notify. And this is going to take a, let's just call it a pad number. Well, let's just call it a message. And a message is going to look like, it's going to look like that 3 array data that we were sending earlier. So what we're going to do is object.values this.outputs for each. So this is going to take every output, and we're going to just output.send message. So we're going to just send this message that gets passed into Notify to every output that exists on the MIDI controller. Okay. And you know what? We'll pass in the name of the device too. If output.name is equal to whatever name we pass in, or if there is no name, then we send it. So this will only send to whatever output we're going to use this device name in that call. And we're going to say, if that output has that name, then send this event. Cool. So notify. What we're going to do is we're going to take our MIDI. We're going to say Midi Notify. And there's going to be some data, which we'll define in a second. And the name is device. Okay, so we are going to send an array of data to a device. Let's call notify. Up here when we initialize. And we're going to make a loop. So we're going to send a note on, then 100 milliseconds later, a note off, then a note on again, then a note off, then a note on. We're going to call something over and over again. The best way to do that is going to be just recursively defining this in a loop function. So the loop is basically going to take, it's going to be in here, and then we'll start the loop down here. So the data we're going to send, I happen to know that the note off event equals 128, and the note on event, which is going to light it up, is going to be 144. So note off will turn the light off. Note on will turn the light on. That's what we're going for on channel 1, which don't worry about it. Channels like walkie-talkie. We get 16 channels. We're only worried about 1, so none of this matters. Channel 2 would be 129. Channel 3 would be 130. It's a whole nother thing for a whole nother time. Okay, so we want to send first a note on. That's the first parameter. The second parameter is which pad. So we already know pad 48. And then a value, 0 to 127. So this is going to be our note on information. So instead of this, I'm just going to say, send this note on event. Let's see if this works by itself. I'm going to put this right here, and we are going to refresh. Boom. See that lit up? Wonderful. So the note on event is working. And then we are going to set time out, note off, pad 0, and then device to make sure it's this device, and that needs to be in a function, which will then, what are we missing here? Goodness, this is getting long. Okay, Midi Notify that. We're going to do that after 100 milliseconds. And then we are going to set interval loop every 200 milliseconds. So every 200 milliseconds is going to call this. Actually, we'll just do it every 100 milliseconds. This is way better. No. It needs to be different times. Sorry, almost had an idea. I was going to call the note off at the beginning, but then we're going to be flashing so fast you won't even notice it. So we'll call the node off 50 milliseconds. We'll set an interval every 100 seconds, and look what we have here. I don't know if you can see that with the frame rate. I'm going to slow it down just in case, but it's flashing. I'm going to slow this down to 100 and then call this every 200. Boom, there we go. That's a little bit slower. And if we wanted to, we could slow it down even more. Now, I'm fine with that, but let's say I'm holding it down. I want the light to respond. So all we need to do here is say if we aren't holding it down. Remember, this is set when node is on is true. So as long as on is false, let's just actually do this. If it's on, we're just going to return out of this function. Otherwise, we're going to call these two things. So that is going to flash, but if I hold this down, it's going to stay down. It's not going to accidentally call it off or anything like that. And then as soon as I let go, it's going again because we're off. Perfect. And actually, I just saw a bug. So if we want to say if we're not on, and then we're also going to do it down here. I know it's a little redundant, but this is for the best. So that when this thing gets called, remember it's scheduling at 100 milliseconds in the future. And so we want to check to make sure we're still not on at that point in the future. Otherwise, it'll go on, I press, then the scheduled off happens while I'm holding it down. We don't want that to happen. We want to check if I'm holding it at that point. So we check it again right here. Inside of the function that's set timeout. Okay, so we have a flashing dot to know which thing to do, and we've got a knob that can control that too. Now, when you're doing this, you're going to have to specify your device name up here, the pad ID, and the knob. The way you're going to do that is you're going to look at a.value for the knob ID. So when you touch that knob, what's a.value when it's a mode change? When it's a node on, node off, you want to see what a.value is there as well. That'll tell you what pad number to put in this 48. And then aftertouch is you might have to use polyrhythmic. What is the polyphonic? I didn't have to look. Polyphonic aftertouch. You might have polyphonic aftertouch, in which case b.ratio will be this, and then you don't even have to track on and off. You can just do a.value is equal to pad. That's what polyphonic aftertouch will give you, is it'll give you this, which we don't have. So anyways, this was rough, but it's meant to be rough because this stuff is always rough. I hope you were able to at least get a little bit from this. Let me bring my face back. This was fun. One little last thing here that I'm going to drop in so that you get to see. I made another fun function, which I'll leave in the code. That does, basically, I can notify animation. So these are a bunch of different pad numbers in a certain order, so that when I reload this page, I get this. Right? Imagine all the fun things you can do, especially with other types of controllers that light up. Anyways, hey, sorry, I forgot to mention I've got something to help you kind of figure out what your device does. It uses the same library that I'm going to give you access to via GitHub. I'll put that in the comments. But it's a code pen. So this is the pen. I'll include a link to it in the description. But basically, any device that's plugged in, it uses the same API and tells you each event. So I can just tap something here. Let me get out of the way. And then maybe we'll zoom in. Move this over. But I am tapping a button and it's telling me the event type, value A, which is a note of 36, and then value B, which is velocity of 0. Here's our aftertouch with different pressure, 0, 57, 84. You know what, while we're here, let's just make this show a little bit more history. I don't know why I keep sending that twice, but oh, folks, we're about to quickly fix this on the fly. If initialize input, if return. This was happening earlier. We were getting double events. This will fix it. See how this is occurring twice? That's because it's being initialized twice because of the way this thing works. So basically it was firing 2 for every event. That is now fixed, and I'm going to fix that in the original source code too. So now when we run this, we should only get 1 event per. Yeah, there we go. Perfect. Okay, cool. That was my bad. You learn every day, right? Here, let's just change it here too. So I'll show you. When we initialize the input, that was occurring twice. We basically just need to say, if this already exists, return. And that is not how you spell return. Perfect. That way we're not adding 2 listeners. That's what was happening. Okay, cool. So I'll show you, I'll send you a link to this. That way, when you plug in a device, you'll be able to see all of its information here, and you won't need to like set up the code to get that information. You can just look here, figure out all of this stuff, and then you can kind of plug it in. I wrote some helpful notes here. Like there's a log on line 23 to figure out what these are, et cetera, et cetera. I put some other comments in here to kind of help out. I also neglected to talk about some of the CSS. I put some helper comments here just to describe what all of this is. It's really less complicated than you think. I need to put a comment here as well. Anyways, I hope this was helpful. Thank you. Stay optimistic, just in general, but also in code. Stuff gets easier, and I'm sure everything else that's going on will too. All right, take care.